All right, let's get right into it. You look at an elephant or maybe a blue whale and you think, wow, that's got to be the biggest animal possible. But it turns out, Earth's history is like a gallery of monsters that would make today's giants look kind of small. So we're going to dig into the science and figure out why our planet was once a world of titans. There's this quote that just nails it perfectly. Modern animals often seem like miniature echoes of their ancient predecessors. I mean, think about that. It's this idea that the world we live in is really just a scaled-down version of what came before. Today's apex predators are just echoes. And that, right there, is the big question. What was going on back then? Was there something in the air? Something in the food chain? Was the entire rulebook for how life worked just completely different? Well, let's find out. To really get a feel for this, let's start with a predator we all know, and then introduce it to its, much bigger ancestor. Okay, so the modern saltwater crocodile. This animal is no joke. It's a perfect killing machine, an apex predator that has been doing its thing for millions of years. By any standard we have today, this thing is an absolute beast. A really big one can stretch out to 6 meters. That's nearly 20 feet, longer than your average car. Now just keep that number in your head for a second. 6 meters. Because if we jump in a time machine and head back 110 million years to the Cretaceous period, well, there was something else in those rivers. Something that makes our modern saltwater croc look like a pet lizard. Meet Sarcosuchus imperator. We call it super croc, and for good reason. Just look at the scale of this thing. It wasn't a little bigger, it was twice as long, around 12 meters, and weighed up to 8 tons. We're talking about the weight of a bus. So the real question is, how on earth did it get that huge? Well, a huge part of the answer was on the menu. Sarcosuchus didn't live in our world. It lived in a world with the supersized food chain. It wasn't just eating fish, it was big enough to snatch actual dinosaurs from the water's edge. So there's our first big clue. The environment itself was just bigger. An ecosystem teeming with giant prey doesn't just allow for a giant predator, it actively encourages it. But that's only one piece of the puzzle. Now, let's switch gears. We're leaving the giant reptiles behind and shrinking down to the world of insects. Or, maybe shrinking isn't the right word here. We've all seen a dragonfly. They're these delicate, incredibly agile little hunters, zipping through the air. They're pretty amazing, a true marvel of flight. A big dragonfly today might have a wingspan of about 12 centimeters, so just under 5 inches. You could easily hold one in your hand. Got it? Okay, because now we're going even further back in time, 300 million years ago, to a period called the Carboniferous, and the things flying through those ancient forests were something else entirely. Say hello to Meganeura, and just look at that wingspan, up to 70 centimeters. That's over 2 feet across. This wasn't an insect as we know it. This was a flying predator the size of a hawk. And the reason for this brings us to our second major clue for ancient gigantism. The secret, it turns out, was literally in the air. Back in the Carboniferous, Earth's atmosphere was packed with oxygen, about 35%, compared to the 21% we have today. That extra O2 was basically high-octane rocket fuel for life. And here's why that mattered so much for insects. They don't have lungs like we do. Instead, they have this network of tiny tubes that lets air just kind of diffuse into their bodies. With so much more oxygen in the air, it could get way deeper into their tissues, fueling a much larger body and shattering their normal size limits. And they had another huge advantage. There were no birds yet, no bats, no pterosaurs. These giant dragonflies were the undisputed kings of the sky. They had the whole airspace to themselves, with no real competition and nothing hunting them. Okay, so we've got a supersized menu for the supercroc and super oxygenated air for the giant dragonfly. This all leads us to the big takeaway. Why don't we see anything like this today? And the answer is pretty straightforward. The planet's recipe for making giants just doesn't exist anymore. The key ingredients are gone. The crazy high oxygen levels, the massive ecosystems with huge prey, the totally different predator-prey dynamics. Our world just plays by a different set of rules now. And this really is the most important thing to understand. Evolution isn't some straight line where things just get bigger and bigger forever. Size is a direct response to the world an animal lives in. The ancient titans were perfectly built for their world, just like today's animals are perfectly built for ours.
Which leaves us with one last, kind of mind-bending thought. The planet has changed before, and you can bet it's going to change again. So, if the conditions that created these giants ever came back, who's to say the Titans couldn't return?